This is 3.1, task 1, part 2. So we're starting at number 4. Before we were solving by square roots and then factoring to see if we got the right answer, or not factoring, excuse me, graphing to see if our square root answer matched our graph answer. Now we will be solving by factoring. And the steps to solving by factoring are number 1, set it equal to 0. So we want to know when the y is equal to 0, or when x minus 3 times x plus 4 is equal to 0. So what x gives us a y of 0, because that'll be where it crosses the x axis. Step number 2 is to factor. But this is already in factored form, so we're done. Step number 3, and this is why we like this, is to set it equal to 0 and solve. And what I mean by that is to set the factors equal to 0. Okay, this equation right here is x minus 3 equals 0, and this equation right here, x plus 4 equals 0. And the reason that works is we have two things, this times this equal to 0. The only way to get two things multiplied together to equal 0 is if at least one of those things are 0. So we call that the zero product property rule. And it says that we could be assured that at least one of those things at some point is equal to 0. And so now we want to figure out which x makes them 0. Well, if I solve here, add 3 to both sides, we get x equals 3. And if I solve here, minus 4 from both sides, I get x equals negative 4. So the solution to this equation algebraically is 3, negative 4. That means it's going to cross the x-axis at 3, negative 4. Okay, and you could say, but hey, Cletus, it was already in factored form. Didn't I know that the answer was just the opposite of what's in parentheses? And the answer is yes, that's your P and Q from factored form, but this is the algebra as to why we've been able to do that. So now let's go ahead and graph it. I'm going to really rewrite it. So again, as I was saying, P and Q, this is factored form. So what we had a 1, x minus 3, and x plus 4. And just like we know from Unit 2 then, my x-intercepts are, I had opposite signs. Oh yes, positive 3, 0, and negative 4, 0, which is what we found algebraically. And then if you were to look at your yellow sheet from the end of Unit 2, it would say to find the axis of symmetry, go halfway in the middle. And the problem with this one is it's a fraction. So sometimes graphing by hand is not always super easy. But that's okay, it's not too bad of a fraction. It's x equals negative 0.5. And then what we know from Unit 2 is to find the vertex. We could plug that negative 0.5 into the equation. So negative 0.5 minus 3 times negative 0.5 plus 4. Everywhere there was an x, we put negative 0.5 because remember x is in, y's come out. And if you were to crunch that number on your calculator, it's weird, but you would get negative 12.25. This is kind of an example of when graphing's not super nice. And yes, it's off my graph, 11, 12, and a quarter. Okay. So my vertex is at negative 0.5, negative 12.25. Remember, this is a develop understanding task, so your job is just to follow along, pay attention, do the best you can, and then the understanding should come. The next thing we want is the y-intercept. And what we learned in Unit 2 is that if you plug in a 0 for x, you will get your y-intercept, and this would be negative 12. Again, I'm either doing that in my head or using my calculator, so I know it's going to cross 0, negative 12, which is right here, and it's going to look like that. Oops, not a straight line. There we go. Okay, and remember, the domain of these is always negative infinity to infinity, because if there's a little dude walking on here, as he goes up, he's going to go left forever, and as he goes right, he's going to go, or up this way and this way. He's going to go left and right forever. And my range, the lowest he could go as he's walking is negative 12.25. The highest he could go is infinity. So negative 12.25 to infinity. So we've got our graph, and notice that our graph backs up our answer, and that they're going to cross the x-axis at 3 and negative 4, which is what we call solutions. All right, so we're also going to do this one, but this one is different because it has not set equal to 0. So, nor is it factored. So what we need to do is get it equal to 0. So we could minus 1 from both sides, and if we did that, we would get negative x squared minus 6x, negative 7 minus 1 is negative 8, equals 0, and you could factor that. It's kind of unfortunate because there's a negative in the front. So you'd want to factor out a negative 1 first, because negative 1 is the greatest common factor. Oops. Negative x squared, divide out negative 1 is x squared. Negative 6 out, divide out negative 1 is positive 6. Negative 8, divide out negative 1 is positive 8. And then we could go on and continue to factor this. So that's using our trick of pulling out the greatest common factor to get an a as 1. The other thing we could do, and again, I wouldn't give you one this hard on the homework, but I'm just showing you, is instead we could have added. We could have moved this stuff to the other side. So I'm going to add this to both sides. And I'd get x squared plus 6x, and then 7 plus 1 would be positive 8. So notice we get this part the same, but this one would have opened down, and this one will open up. That's okay. They're still going to cross the x-axis at the same spot. It's just one's going to open down and one's going to open up. And since all we're worried about is where it crosses the x-axis, it doesn't matter. So I'm going to take this one because I think it's easier. I don't have to deal with a negative 1. And I'm going to do simple factoring. What multiplies to 8 and adds to 6. Okay. So this is the a equals 1 factoring, and I get 1 and 8. 2 and 4 adds to 8. And if I look at that, 1 and 8, 2 and 4, multiply to 8. And if I look at it closely, I can see that 2 plus 4 adds to 6. And so I am done. All right. And now I could keep going. I could set the baby equations equal to 0 and solve. So minus 2 minus 2. I know it's going to cross the x-axis at negative 2. And I know it's also going to cross the x-axis at negative 4. Okay, so I have it in intercept form. I can see where it's going to cross the x-axis, so these are my x-intercepts. And then to get the rest of this point on this task, I'd like you to use this information to graph this quadratic equation, bring it to me, and show it to me for points. Thank you.